Hello everyone, welcome back to Math Jamboree. In this video we have another AP Precalculus type of a question from the topic of polynomial functions and complex zeros. Let's solve it together. The polynomial function p of x is equals to x plus 4 times x squared minus x minus 5. Which of the following describes the zeros of p? A. P has exactly two distinct real zeros. P is given as P has exactly three distinct real zeros. C. P has exactly one distinct real zero and no non-real zeros. And D. P has exactly one distinct real zero and two non-real zeros. To solve this equation, we're talking about the zeros. To find the zeros of any polynomial, we will look for the factors and we will equal the factors equal to 0 and then solve for x. So technically, there are two factors of this polynomial. So if we'll make them equal to 0 and solve it for x, we will find its zeros. So from this expression, by taking away 4 from both sides, we're going to have negative 4. The first zeros is negative 4, which is the root. And this is x and x. When you multiply, what numbers do you get? 5. It's 5 and 1. But when you add them, do you get negative 1? So this way, this factoring didn't work. In this case, if this factoring doesn't work this way, you're supposed to use quadratic formula to find its roots. In a form of a quadratic equation, ax squared plus bx plus c equals 0, in this given expression, our value of a is the number in front of the x squared, which is 1, and b is negative 1, and the c is negative 5. And we all know that the quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. So in this case, if I will just go ahead and substitute the values in, x equals negative 1 plus or minus square root of b squared is negative 1 squared minus 4 times 1 and times negative 5 divided by 2 times 1. If I will simplify this, negative times negative is positive 1 plus or minus square root of, in the square root, when you look at it, we have negative 1 squared, which is positive 1, and negative 4 times negative 5 makes positive 20 times 1 is positive 20 over 2. So I can go ahead and write x1 as negative 1. I will take the positive value, negative 1 square root of 21 over 2. And for the x2, we can write as, let me see, the b is not negative 1, it's positive 1. Sorry about that. And positive 1 minus square root of 21 over 2. So this is the second factor. It's a real factor. It's not a non-real zero. So because square root is positive. So we have found 3 roots of this polynomial function, which means that p has exactly 3 distinct real zeros. In that case, our correct answer for the specific question is choice B will be the answer. I hope you found this video helpful. If you did, please give it a thumbs up. If you have questions or comments, you can always leave it below there. Thank you and see you next time. Bye-bye.